All right, I wanted to include this in the previous lesson, but it was getting kind of long, so we'll do a separate one here with this, with a couple of examples of how to use intensity and discover the loudness, which is expressed in decibels, beta here. So I'm going to start by considering the intensity in decibels, the intensity level in decibels, or the loudness, if the sound is at the threshold of hearing. In other words, the minimum sound level, minimum intensity that humans can pick up. So I don't know, if maybe I shouldn't have called it intensity level in decibels, but when you see in decibels, what you want to realize is these dB, it's a nice convenient unit based on the logs that describe the loudness of the sounds that we hear. Okay, and so let's consider what that is at the smallest sound level that we can pick up. So the formula is 10 log base 10 of the ratios of intensities, namely the intensity under consideration compared to the reference level, in this case, the threshold of hearing. So what is that intensity level? Well, if the intensity in question is the threshold of human hearing, then it just looks like this. It's the ratio of, a trillionth over a trillionth, 10 log base 10 of that, which is 10 log base 10 of 1. Now, the log of 1, the number for that is, well, this number is the number you get when you raise 10 to the power of something. What power do we have to raise 10 to get 1? And the answer is 0. All right, so it's 0 dB. 10 times 0 is 0. So 0 decibels is the sound level. Oh, that's kind of convenient. Guess what? If we consider the sound or the loudness of a sound at the threshold of human hearing, we get 0 decibels. It's like that's the beginning. It's the beginning point. Oh, it's so logical. I like that. So now let's make the intensity 100 times more intense. Well, if it was 10 to the negative 12, that makes it 10 to the negative 10 watts per square meter. Put it into the formula, and now it's 10 log base 10 of the new intensity 100 times more than the original. So that's 10 log base 10 of 100. So what power do you raise 10 to get 100? And you know that number is 2. So the log base 10 of 100 is 2. 2 times 10 is 20. The answer is 20 dB, 20 decibels. In this scale, every increase in intensity, this number here, when we increase the intensity by a factor of 10, it raises the sound level by 10 decibels. Because you have to raise the power of 10 by 1. 10 is here, raised to some power to get this number, and then you're multiplying it by 10. So every 10 times intensity, you raise that by 1 and multiply it by 10, so it increases it by 10 decibels. I fear that I'm saying too much at this point. Okay, back up the video a bit if you need to, or just move on. Okay, so that's an important point, though, as we'll see in the next example. Faint rustle of leaves, sound intensity of about 10 decibels. All right, so that is the sound level, which means it's based on the reference of this being 10 to the negative 12 is the threshold of hearing. That means that the intensity of that would be 1 times 10 to the negative 11. If you do that, you'll get the 10 decibels. Okay, but I'm deviating from the problem a little bit. A quiet radio is 1,000 times more intense than that. What's the sound level in dB? So it's 1,000 times more intense. The nice thing about that nice even power of 10 is 1,000 equals 10 times 10 times 10. And every time you increase the intensity by a factor of 10, the factor of 10 corresponds to an increase of 10 decibels plus 10 decibels. So 10 times 10 times 10 is equal to 10 decibels plus 10 decibels plus 10 decibels. And that, of course, is equal to 30 decibels. So that's how much more sound level we have. So if we started out with 10 dB and we raise it by 30, the loudness of the quiet radio is 40 decibels. Yay! A little confusing? Let's do one more example here. A whisper. Shh. It has an intensity level of 25 decibels. A loud rock concert, which I will not try and simulate, is about 120 decibels. How many times more intense is the concert? What you're going to do is, well, let's see what we need to do. Okay, there's a difference in dB here. First thing I'm going to do is figure out what that is, and it's 95. So 95 is the difference there. So that difference in decibels can be applied to the same formula. It's related to the ratios of intensity through this logarithmic expression. So 95 is 10 log of the ratio of the 120 decibel concert to the 25 decibel whisper. Yep, that's what it is. All we're going to do then is we're going to basically just solve for this ratio. That's what we want to do. So divide by 10 to begin with. 9.5 is log of those intensities. Now, we got the log. How do you get rid of log? You raise 10 to the power of that log, and it negates it. 10 to the log of is basically doing the opposite what logs do. So it makes that go away, and we end up with just the ratio of intensities. But you can't do this to one side of the equation unless you do it to the other side, so let's go ahead. So 10 to the 9.5 is equal to the ratio of intensities. Very good. So therefore, the intensity of the 120 compared to this is simply 10 to the 9.5. You kind of need to plug that into your calculator, right? Most of us do. So it's 3.16 times 10 to the 9th. It's a lot. Times I0. Really, I'm saying I0. I mean the I25. In other words, the reference. The reference in this case is 25 dB. That's the I25. So that's the reference in general. So I'm using the I sub 0, I naught nomenclature here. And so, wow, the rock concert is 3 billion times. The sound itself is 3 billion times more intense, which only corresponds to 95 decibels. 95 decibels is a lot. All right, so those are a couple of good examples of how intensity and loudness correspond to each other. And just real quickly, I'm sure there's a lot better pictures out there, but here's, here comes the sound, ear canal, and the Hamel anvil stirrup system. All right, the cochlea. This is really an amazing organism where different wavelengths trigger different hair stimulators inside this thing and send a signal to the brain, auditory nerve that goes to the brain that gives us the perception of sound, which we have no idea how that really comes about, our actual human perception, because our brains are just too complicated for our brains to figure out, which is actually a logical necessity, but let's not get off on full. So here's the cochlea again, and different wavelengths are set up, standing waves in this cochlea here. Standing waves are set up, and where you have the where you have the antinodes, you have stimulation of the nerve centers in that region that correspond to different frequencies. It's really an amazing system. Just kind of one more thing here, looking at, we've discussed the threshold of hearing. Here's a graph, intensity and frequency. So in terms of the human perception of hearing, the threshold of hearing, the minimum level that you can hear, I said, is we defined as 0 dB, or 10 to the negative 12 watts per meter squared, corresponds to a 1,000 hertz tone. And likewise, the threshold of pain, 120 decibels, 1 watt per meter squared, and that's the threshold of pain at 1,000 hertz. but our ears are not linear with the various frequencies. So the intensity versus frequency is complicated as well. I'll just point out that this is why to really hear bass in music, it takes a lot of energy to produce the bass, to have the perception that you want to hear, like at a rock concert or just in your house. Because the threshold of hearing, look at 50 hertz. It's a very low tone, but it sounds pretty cool in the right song. Well, the threshold of hearing isn't at 0 dB. It's not 10, 20, 30, 40. It's more like 50 decibels. My goodness, that is 10,000 times the energy needed just to hear it at all compared to the 1,000 hertz tone. So this is a significant reason why the main energy or power in a stereo is tasked with producing the bass because of the response of our ears. And of course, music is for us, right? It's not for physics. It's for the human condition, the human experience. So I thought that might be kind of interesting to you. All right, that'll conclude our examples at this point. And going forward, we're going to look at sources of sound. And there's a few of them. See you next time.